Hi class, this is part 3 of section 3.5. Okay, we're up to example 6. We want to graph each of the following by transforming the given graph of y equals f of x. Okay, so we have in our picture a semicircle, basically the bottom half of a circle. All right, so for the first one, we want to graph y equals f of the quantity x plus 2 and then minus 1. So x plus 2, that's going to be a horizontal change. Remember, horizontal changes is always the opposite of what we might think. So plus 2 is really going to move the graph to the left 2 units. The minus 1 is going to move it down 1. Okay, so I'm gonna pick 3 points to focus on, and we'll move those 3 points as we said we would. Okay, so I'm taking my y-intercept, so 0, -4. I'm going to move it to the left 2 units and down 1. I'll do that in blue. All right, same thing here for my x-intercept, so 4, 0. I'm going to move that to the left 2 units and down 1. And then same thing with this second guy here, left 2 and down 1. So I have those 3 points. Otherwise, the graph is exactly the same, right? We have what's called a rigid transformation. Okay, so I still have my semicircle, just shifted left and down. Okay, so there it is graphed using Desmos. Okay, let's move on to the next one. So we have y is equal to 2 times f of x. So this is going to be a vertical stretch of the graph. Okay, so we want to vertically stretch it by 2. Okay, so I'm going to go back to my original function. The places where we were on the x-axis, those are going to stay the same because the y values were 0, and multiplying 0 times 2, you're still going to have 0. My y-intercept is going to change, right? So this was at -4. It's going to be all the way down here at -8. Okay, and so here would be the graph. It's what's called a non-rigid transformation, so the shape changes. Okay, so again, x-intercepts stay the same, okay, because I'm just multiplying everything by 2. So if you're at 0, those stay 0. But for example, -4, I multiply that by 2, and so we're down here at -8. Okay, so there it is graphed with Desmos. Okay, next we're going to graph y equals -f of x. The negative is outside, so that's going to be reflected about the x-axis. Okay, so again, I'm going to look at this point here, 0, -4. That gets flipped over the x-axis, so we're going to be at 0, +4. Otherwise, those other 2 points stay the same. My x-intercepts, again, stay the same because I was at 0, so multiplying by -1 doesn't change those points. Okay, so in blue, we have the graph of the opposite of f of x, so we basically get the top portion of our circle. Okay, so there it is with Desmos. And then finally, the last one, y equals f of 2 times x. This time the 2 is with the x, so it's going to be a horizontal change. Remember, the horizontal changes are always the opposite of what we might think. So you might originally think times 2 is going to be a stretch, but it's really going to be a compression. So we have a horizontal compression. Okay, so I'm going to look again here at my graph. So where I was at 4, it's going to be horizontally compressed. So I'm going to come in and compress by 1/2, right? Because we have that 2 in there. So I'm compressing everything in, basically dividing everything by 2. So where I was at -4, I'm now at -2. Where I was at +4, I'm now at 2. This time the y-intercept stays as it is. Okay, and then we'll just sketch this graph. Okay, so the graph that we originally had in black, it's like I'm just pushing it, I'm compressing it together. And so we get this kind of this half oval shape there. Okay, so there it is graphed with Desmos. Example 8, determine the function obtained by the series of transformations. All right, so we're starting with the graph y equals x squared. So that's our parabola. We're going to move it to the left 2 units. Okay, so the first one was y equals x squared. Oh, sorry, let me erase this. Down 3 units. Let's do that first. So we're going to shift the graph down 3 units. So this gives us the graph of y equals x squared minus 3. And now we want to move it to the left 2 units. Okay, so there's, again, just a rough sketch of the graph. Left 2, that changes with the x. So, and remember, it's the opposite of what you might think. So moving it to the left 2, we actually have x plus 2. So that's quantity squared. And then I still have my minus 3. And now I want to take this guy and reflect it about the y-axis. Okay, so let me come over here. So if I take this graph here and reflect it about the y-axis, I'm going to move over to positive 2, but I would still be down at negative 3. Okay, so we have now positive 2, negative 3, and the graph is still opening up. So it'll look something like that. Okay, so now what's the function for this graph here? All right, so it must be related to what we had in the last step. Reflection about the y-axis, so the negative is with the x. So let's double check this because the order makes a difference, right? So I want to be able to plug in 2 and come up with negative 3 as my answer. Okay, so if I plug in a 2 here for x, I take the opposite to get negative 2. Plus 2 would be 0. We're at 0, and then subtract 3. So we're good to go. Sometimes when you have a reflection about the y-axis and you also have a horizontal change, we just want to be careful of the order in which we do those. Okay, so notice that in the directions we said that we're moving the graph to the left 2 units. In the final picture, it looks like it's been moved to the right 2 units. But again, that's because of the order. So we first moved it to the left 2, but then reflected it about the y-axis. Okay, so when you do these problems in your homework, follow the order in which you're given the transformations. Okay, and then always double check it at the end. So let me write down how I checked it. So again, the key point is this vertex. Okay, so in my picture, 2 was the vertex, so I just wanted to make sure I was going to get negative 3 back as the y value. Okay, and if I plug in a negative 2 to my function, I have if I plug in a 2 to my function, I have the opposite of 2, but then I add 2, so we're at 0. Squared is still 0. Minus 3 gives me the ordered pair 2, negative 3. So that worked out. Okay, so that's the function that I was looking for. Okay, so now we're kind of doing the opposite. This time we're given the graph of a function and we want to come up with a formula that will lead to this graph. So we see that we're starting with the absolute value function. It has been moved to the left 1 unit, down 3 units. And it's also, you could say opening down. I'm okay with that. This is equivalent to saying it's been reflected about the x-axis. Okay, so we know there's going to be a negative involved somewhere. Okay, so let's see. If I start with the fact that the graph has been moved to the left 1 unit, so we would have the x plus 1 inside those absolute value bars. Our graph is opening down, so there's going to be a negative out front. Okay, and also has been shifted down 3 units, so we want a minus 3 here at the end. Okay, and let's plot a couple points just to check it. So if we let x equal negative 1, we would have that y is equal to the opposite of the absolute value. Let's see, negative 1 plus 1 is 0. So we're taking the absolute value of 0, which is 0, minus 3. So we get negative 3. So that's good. That point works. Okay, and let's also try when x is equal to 0. Make sure this guy works out. So we have the opposite of 0 plus 1 is 1. So I'm taking the absolute value of 1, but then I have the opposite of that. So the absolute value of 1 is 1, but then I take its opposite, so I'm at negative 1 minus 3. So we end up with -4, which is good because that's where we want it to be. Okay, so it is a good idea to check at least 2 points. 3 points would be even better, but I'm out of room, so I'll just do 2 points. So if you made a mistake, sometimes 1 point would still work out, but that's why it's good to check at least 2. Okay, so there's the formula that leads to the given graph. Even and odd functions, I'm going to stop this video here and we'll pick up with even and odd functions in the next video.